यासीन से د دې ما ډیفینیشن اوریدلی الکه سر جوین کې جوړه ښا
सर जॉइन को
د دې ډیفینیشن ما کیمرا باو
जी जी
د دې ډیفینیشن ما اوریدلی دا
हाँ
سی
सर
و
दस
چې
को
لکه ما ته سر نه کوېسچن وکړ ما یو ځای کې دا سی اوریدلی یو ډاکټر نه چې هغه وی چې behavior you learn from your home environment, from your parents, from your school, colleges, universities, whatever you learn, and the way you behave that's your attitude.
जी अस्सलाम वालेकुम हेलो
ना खुदा
अस्सलाम वालेकुम सर
अस्सलाम वालेकुम
सर
रुम्बे खुदा कंफर्म के everybody is able to hear जी
अस्सलाम वालेकुम
जी अस्सलाम वालेकुम how many people are here कितने लोग हैं आप
सर फिलहाल तो मेरे ख्याल में
8 स्टूडेंट है ऑलरेडी जॉइन
ओके ओके
8 स्टूडेंट है सर
अच्छा
9 हो गए सर
ओके ओके राइट सो मैं इस तरह कर लेता हूँ कि आई वुड जस्ट शेयर माय स्क्रीन so that all of you are able to share my screen and you can then confirm whether you are able to have my screen or not.
Yes sir.
Yes sir.
जी आपको मेरा स्क्रीन शेयर हो गया है?
जी जी बिल्कुल
सर राइट
Okay, okay, that's good. Okay, and let me see whether it would be automatically recording या इसमें हमें record करने का option देना चाहिए because I'm using Zoom for the first time.
सर already recording on है.
Okay, okay, बस फिर ठीक है, it's okay, that's good. Okay, जी 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 please.
सर आपकी खुद रिकॉर्डिंग ऑन है सर आप जो ले रहे हैं ना सर
जी
तो वो नजर आ रहा है सर हमें
okay okay is it okay can you see the slide right now
जी जी yes okay sir
yes sir
okay
सर रिकॉर्डिंग के लिए आपकी परमिशन चाहिए सर
जी तो आप बताएं कहाँ पे परमिशन है तो मैं वो ग्रांट कर देता हूँ
सर आप पार्टिसिपेंट पे क्लिक कर दे
where is participant
सर नीचे सर
let me just look where it is
सर नीचे सर अगर आप आइकॉन देख लेना तो सर म्यूट स्टार्ट वीडियो और पार्टिसिपेंट चैट सारी चीजें नीचे सर मेंशन है
all right let me just check it out नहीं अगर यहाँ पे रिकॉर्डिंग हो रही है तो वो मैं फिर आपके साथ शेयर कर लूंगा अगर इसमें हम हमारा टाइम वेस्ट होता है ना लेट मी सी
यस इट्स ओके सर
ठीक है ना
ठीक है
ऐसा ना हो कि हम इसी में सारा टाइम गुजार दें तो अगर ये क्विकली हो सकता है तो ठीक है अदरवाइज वी विल जस्ट ठीक है फिलहाल छोड़ दें इसको मेरा ख्याल है ये ऑलरेडी रिकॉर्ड हो रहा है ना राइट ओके
ओके सर
okay how many participants are here
sir 10
and how many more we can
5 are still remaining sir
okay so let's wait for 1 or 2 minutes मेरा ख्याल है 1 या 2 मिनट का जरा सा वो कर लेते हैं in the meantime I will just tell you what would be the procedure that we would have today एक बात तो ये है कि I think after 40 minutes there would be a disconnection तो फिर आपको reconnect होना पड़ेगा ना ये तो आपको पता होगा ना ठीक है
जी
सर इसमें इस तरह है कि वो डिस्कनेक्शन सिर्फ आपकी तरफ से होगी और वो आपको स्क्रीन पे उस टाइम पे आएगा जब आप एक्सेप्ट करोगे तो हमें कोई डिस्कनेक्शन नहीं होगी
ओके ऑलराइट करेक्ट ठीक है राइट
हमारी तरफ से मतलब हमारी तरफ से डिस्कनेक्शन नहीं होगी आपको एक आइकन आएगा जब आप जैसे ही आप एक्सेप्ट करोगे तो बस हमारा क्लास कंटिन्यू रहेगा फिर
ओके करेक्ट दैट्स गुड Okay, so agenda for today is to start with the basic ideas of regression. थोड़ा सा regression के ज़रा सा fundamental है, लेकिन as you would appreciate at the end कि I want to give you a fundamental idea of regression. For that, I would just take this hypothetical example. इसको मैं quickly discuss करता हूँ. Then we can go for our usual econometric modeling discussion. So if possible, maybe we can go for a status session at the end. लेकिन आज ज़्यादातर discussion हमारा ये होगा कि what are the fundamentals of regression models? Because if you remember from our previous lecture, उसमें हमने ये discuss किया था कि econometric models are basically regression models. ठीक है? So in today's lecture, we would start from a very fundamental idea behind regression analysis that would make the foundation of all our discussion for the rest of the lectures. तो ये एक छोटा सा example है जिसको मैं शुरू में discuss करना चाहता हूँ. But I hope कि if you capture this particular idea, this would help us a lot later on in all our discussion of econometric models. In a sense, the discussion that we would have today would serve as a foundation for all our econometric models, right from simple to more advanced till the end of the course. तो ये इससे हम start करेंगे. I would also share the slides that I'm using, so don't worry because you will get all these slides. अगर आपके पास already नहीं है तो मैं आपको share कर दूंगा either on the AMS of the Qurtuba University, or maybe I can also send you directly through email. लेकिन जो भी proper way होगा, you will get every material. And in a sense, whatever we are using in the online lectures or whatever we are discussing, everything will be available to you, right? In next lectures में मैं ये कोशिश करूँगा कि if there is something that you don't have, तो मैं आपको advance में वो भेज दूँ ताकि you are ready for that. क्योंकि बाज़ वक़्त ये होगा कि if the thing is in front of you, it is available to you, तो वो उसकी ज़्यादा utility होगी. Okay. Somebody should signal me, give a signal when to properly start our discussion. आप देख लें कि how many participants we have right now.
Still 10, sir.
10, yeah. Okay, मेरा ख्याल है कि इस तरह कर लेते हैं. Just to save our time, we will start our discussion because the recording would be available. तो अगर unfortunately कोई बंदा late भी join करता है, so I hope recording available होगी. So I hope there will be no problem. Let's start our discussion. Okay. So when you want to learn the basics of regression analysis, we would start from the simplest possible regression model that we call the simple regression. I hope you remember in the previous lecture, we had some initial discussion about simple versus multiple regression, right? Just to refresh your memories, simple regression refers to that type of regression model in which only one explanatory variable is on the right-hand side of the equation, while multiple regression contains more than one, two or more explanatory variables. So therefore, some of the fundamental ideas of econometric models will be discussed in the context of simple regression model, which means one dependent variable and one independent variable. Okay, let's start from the basic definition and then discuss the idea, जो कि मैं आज चाहता हूं कि we quickly discuss this particular idea. Okay, this is just in the beginning of this particular slide, as you can see at the top, this is just simple definition of regression analysis. Regression analysis is largely concerned with estimating and or predicting the population mean value of the dependent variable on the basis of known or fixed value of the explanatory variables. All these things will become clear. So if some words in these lines are not clear, so don't worry. But the basic idea behind regression analysis is that you want to study the dependence of one variable on one or more other variable or variables that we call explanatory variable. In the last lecture, I had also told you that dependent variable is also called variable of interest. Sometimes we call it response variable. While explanatory variable is also called independent variable. There are so many other names, like from pure regression terminology, explanatory variable is also called regressor, OR at the end, regressor. But I mean, don't worry, if you are not using the word regressor for explanatory variable, it doesn't matter. चाहे आप independent variable का word use करें, चाहे आप explanatory variable का word use करें, चाहे और बहुत सारे नाम हैं, but I mean, it doesn't matter. As long as you know that explanatory variable or variables for that matter are actually those variables which help us to study the nature of our variable of interest. So हमारा main interest किसमें होता है? Dependent variable. Dependent variable is representing the phenomena in which, as a researcher, we are interested. So whatever we want to study for our research, in the language of regression analysis, we consider that one as dependent variable. And which other thing or things would help us to study our variable of interest, or to, in a sense, explore the nature of our variable of interest, that would be called explanatory variable. As the name suggests, explanatory variable, it is used for explaining purpose. Okay. In the book Basic Econometrics, जो मैंने आपको last lecture में बताया था, written by Gujarati, there is a very fundamental example with which we are starting right now. There is a table 2.1 on the next slide, which looks like this. Okay. Table 2.1 is a fundamental table of interest for our discussion. So maybe in some of the later lectures in our discussion, I will be using the word consider again the data given in table 2.1. So I would like that you take, जिसको आप कह सकते हैं ना, a sort of mental snapshot of this particular table, so that when I talk about the word, when I use the word table 2.1, so it's not necessary कि आप हर दफा table 2.1 को open करके देख लें कि ये क्या है. So just look at the, I would quickly explain what is there in this table, or later on if I use the word table 2.1, so it should be very clear to all of you that what I'm talking about. This table is just giving you a hypothetical data on 60 families, okay? And we consider a population of 60 families. I hope from your previous background, you know that when we talk about statistical treatment of data, हमारे पास दो किस्म का data होता है ना, population, data coming from the whole population, and data coming from the sample. Population is the bigger set of interest, the actual target group, and sample is just a part taken from that particular population. So we are considering this particular data in table 2.1 is representing a population of families. And for the purpose of example, we are considering this data of 60 families, although आप सबको पता है कि in real life, a population of units is much bigger than 60 units. So therefore, you should not worry why we are talking about a population of 60 families. So just hypothetically consider that we are talking about a population of 60 families. And for that population of 60 families, we have considered two variables. As you can see, one is the Y variable here, which represents what? Weekly family consumption expenditure, Y, represented in dollars. And what is the X variable here? Weekly family income in dollars. So both represent weekly data, weekly consumption expenditure in dollars, and weekly income in dollars. And contrary to the usual data set that you observe in real life, जिसमें आपके पास दो columns होते हैं, one column is representing the Y variable, another column is representing the X variable. Here the data has been rearranged in a different format. और आपको अभी मैं बताता हूँ कि what's the reason why we are considering data in this format rather than the usual format. The population of 60 families are divided into 10 income groups, right? Just a minute, just give me one second. Hello, are you with me?
Yes, sir.
Okay.
Yes, sir.
So consider this table, which represents X is an explanatory variable, weekly family income, and Y is a dependent variable, weekly family consumption. A typical example of the Kinesian theory of consumption, all right? जिसमें हम कहते हैं कि consumption expenditure reacts to change in income. But the data has been obtained in such a way that you have considered income in 10 different categories. As you can see at the top of this table, there are 10 different values of X: $80 per week, $100 per week, $120 per week, up to $260 per week. And corresponding to each income level, we have considered the consumption expenditure of the corresponding family. So as you can see from this table, there are 5 families who are earning $80 per week. And the consumption expenditure of these 5 families are given below X equal to 80. Yes? Is there any problem? I hope there is no problem. Okay. Is it okay?
Yes, sir. Okay.
Okay, right. Okay. So just look at the nature of this table. Corresponding to each level of income, $80 per week, $100 per week, and so on, up to $260 per week, we have the corresponding consumption expenditure of those families. So as you can see here, out of the 60 families, 5 families are earning $80 per week. 6 families are earning $100 per week. How can I say that 5 families and 6 families? Because if you see, corresponding to $80 per week, there are 5 different values of the consumption expenditure. So all these families are earning the same income, which is $80 per week, but their consumption expenditure is different, which is quite logical, because even for the same level of income, you cannot expect that the consumption expenditure would all be the same. So these 5 families whose consumption expenditure ranges from 55 to 75, they are earning $80 per week. Similarly, if you look below the figure 100 in this table, there are 6 different figures. So we say that there are 6 families whose level of income is $100 per week, but their consumption expenditure varies from $65 per week up to $88 per week. And similarly, you can interpret all other columns in this particular table 2.1. So all the 60 families are actually represented in the form of this thing. वो जो आपको शुरू में कह रहा था कि usually the data would be in the form of Y and X column. So you can consider, for example, a Y column in which the first 5 figures for the Y variable are these: 55, 60, 65, 70, 75. But the first 5 values of X would all be 80. So in the X column, you will have 80, 80, 80, 5 times 80 figures. And corresponding to those 580 numbers, you will have these things. So you can imagine that this data can also be arranged in the usual manner, but we are not considering it in that style for the time being. So if you consider the nature of this particular data, so corresponding to a particular level of income, we have the consumption expenditure of the corresponding families, right? So 5 families earning $80 per week, 6 families earning $100 per week, again 5 families earning $120 per week, so on and so forth. And if you look at the second last bottom row corresponding to the title total, this is just adding up the Y values. For example, if you just add up 55, 60, 65, 70, and 75, so the total of these 5 numbers is 325. And if you divide this 325 by the number of these families, right? 325 is the total consumption expenditure of these 5 families. If you divide it by 5, you will get the figure in the last row of this table, 65. So what does this 65 represent in the last row of this table? This represents the mean consumption expenditure of these families who are all earning $80 per week. In statistical symbol, we say that this is actually what we call the conditional mean of Y. Why we call it the conditional mean of Y? Because it represents the mean value of Y given X equal to 80, right? Given that X is equal to 80, the mean of the Y values is equal to 65. So this 65 is not representing the overall mean consumption expenditure. Overall, to aapko pata hai na ki if you want to get that, then you have to add from 55, go up to this last number, 191. If you add up all these 60 numbers and divide the total by 60, only then you will get the overall consumption expenditure. But if you look at the figures in the last row of this table, it is representing the mean consumption expenditure, of the families corresponding to a given level of income. So for example, if you look at the second figure in this last row, 77. So what does 77 represent? It represents the mean consumption expenditure of all those families who are earning how much? $100 per week. So we call such mean values, in the language of statistics, we call it conditional mean. So the reason why you can see the title conditional mean of Y in the last row of this table, it is just to represent the fact that these numbers in the last row, they are not the overall mean values of Y, they are the conditional mean of values of Y. Conditional, as I have already explained, condition upon the value of X. So if X is 80, then the mean value of Y is 65. But when X becomes 100, then the mean of Y is equal to 77. If X is 120, then the mean of the Y values, these 5 values, the mean of Y values become 89. So all these numbers, 65, 70, 89, up to this 173, that you can see in the last row of this table, they represent what? They represent, as you can see here, conditional mean of Y. In statistical symbol, we use this notation that you can see, capital E in the bracket Y/X. In the language of statistics, we call this thing as expectation or expected value, right? So when we say expected value of Y, this actually means the population mean of Y. So just from this lecture onward, if someone is not familiar with this terminology, you should make yourself familiar that whenever I will be saying expected value of a particular variable, right? Like capital E of a particular variable. So I would always talk about the mean value of that variable. But remember, when I use the word expected value of something or capital E of something, I would always be talking about the population mean. I would never be talking about the sample mean. Sample mean के लिए क्या notation है वो भी आप देखेंगे कि what is the notation for sample mean. So we just say expected value of Y. अब देखिए इसमें एक है slash, ये vertical bar जो आपका नजर आ रहा है ना, slash, और उसके बाद x लिखा है. अगर ये slash x में यहाँ से हटा दूं और सिर्फ ये लिखूं expected value of Y, then I'll be talking about the overall mean of the consumption expenditure variable Y. तो अगर मैं expected value of Y represent करना चाहता हूं तो उसका मतलब क्या होगा that I am talking about the mean of all these 60 values. Irrespective of the level of income, just add up all these 60 values, divide by 60, and you will get that one. So I'm not talking about that. So the numbers in the last row of this table 2.1 represent expected value of y, और ये स्लैश को हम कहते हैं given x, expected value of y given x. Like अब मैं फिर explain करता हूँ. If I want to say what is 65, so I would say that 65 is something like this. Let me just write it ताकि आपको एंड में clear होके for example, so if I want to write down this 65, right? If I want to represent this number 65, so the more appropriate notation would be something like this: expected value of y given x equal to 80, or this is equal to 65, right? नजर आ रहा है आप सबको?
Yes, sir.
Okay, so this would be the actual sort of understanding, although it's not necessary that you always write it like this. Like here for the first time मैं सिर्फ आपको समझाने के लिए लिख रहा हूँ. Okay, for example, if you look at the numbers in the last row of table 2.1, it would be representing the expected value of y. Again, जिन लोगों को clear नहीं है तो मैं फिर बता देता हूँ कि when I will be using this word expected, I'm actually talking about the mean value. So expected value of y or mean value of y slash x का मतलब ये होगा कि I'm talking about the mean value of y corresponding to a given value of x. So when I'm talking about 65, I'm actually talking about the expected value of y given x equal to 80. And similarly, if I'm talking about the other numbers in this table, so I hope now it will be very clear to all of you that this 77 represent expected value of y given x equal to 100, right? 89 represent expected value of y, or अगर for the first time आप expected value के साथ comfortable नहीं हैं तो आप कह सकते हैं कि 89 represent mean value of y corresponding to x equal to 120. So every number in the last row represent the mean value of y corresponding to the value of x in the top row. So therefore, I would like that when you are looking at this particular table, you should give a particular attention to the top row, which represents my explanatory variable x, and the last row, which represent जिसको मैंने symbolically इस तरह लिखा है expected value of y given x, लेकिन basically what they represent the conditional mean of y, the mean value of y corresponding to a given value of x. Okay, so now I will show you why these numbers are very important, why I'm talking about this stuff for the last few minutes. Now I would like to just tell you, okay, what was the reason of spending that much time on the last row, expanding the last row. Okay, so once you calculate the last row of this table 2.1, the next is the graph that I would like to show you. Now look at the graph. This is a graph which we had briefly discussed in our last lecture, but now I want to explain it from a particular conceptual point of view. If you look at this particular graph, this simply represents a graphical relationship between our two variables, our independent variable x, which in this case is weekly income in dollars, and our dependent variable y, which in this case represent weekly consumption expenditure in dollars. The smaller dots, for the time being, just ignore the line and the bigger dots. For the time being, just ignore that thing. आप इस तरह कर लें कि ये नहीं है. Just look at the smaller dots. Corresponding to each value of x, you see ये जो आपको horizontal line पे नजर आ रहे हैं ना, these are actually representing the top row of table 2.1, right? ये जो टॉप पे आपके पास वैल्यूज हैं, मैंने अभी आपको बताया कि दे रिप्रेजेंट योर द वैल्यूज ऑफ योर डिपेंडेंट वेरिएबल x. So in the graph, the horizontal line represent these x values. Okay. Okay. Now, when you look at this graph, this is actually telling you that corresponding to each value of x on the horizontal axis, there are a number of different values of y. So the smaller dots are just representing those numbers. Like, for example, if you look at the numbers below 80 in this table, there are 5 numbers. And all these 5 numbers represent the y values. Okay? $55 per week, $60 per week, $65 per week, and so on. So the smaller dots in the graph represent these 5 numbers: 55, 60, 65, 70, and 75. So these are actually the smaller dots. Similarly, when you plot the y values corresponding to x equal to 100, when you plot the y values corresponding to x equal to 120, you can see all these things. Okay? So the thing is, if we want to get an idea about the possible relationship between x and y, like for example, as x increases, what happens to the y values? The Kinesian theory of consumption is actually telling us that as income increases, consumption expenditure also increases. वो तो simple एक वो है, आप सबको पता है उसका. Now, if we look at this graph, there are multiple places where it would be doubtful. In a sense, we would be doubtful कि क्या ये theory really it is telling us something right or not. For example, for some places, it's absolutely correct. Like, for example, if you look at the y values, if you look at the y values corresponding to x equal to 80 here on the plot, and then when you look at the y values corresponding to x equal to 100 over here, so it's very clear that if income is lower, the consumption is also lower. But when income increases, the consumption also increases. But there are other consumption levels where this situation seems to be reversed. Like, for example, there are some consumption expenditure which corresponds to a lower income, like 80. But these values are actually higher than the consumption levels of those who are earning, in a sense, more than x equal to 80. So, for example, if I want to explain it from the table, if you look at this table, just focus for the time being only on the first 2 x values, x equal to 80 and x equal to 100. There are some places where it would seem that as income increases, the consumption is actually lower. Like, for example, if you look at these numbers, if x is 80, then there is one family who is earning $70 per week, and there is another family who is earning $75 per week. And when you increase x from 80 to 100, these are the corresponding consumption figures. One of these figures, if for the time being you focus on this number 65, so you see 65 is smaller than 2 numbers in the previous column. So although for this family who is earning $100 per week, their consumption expenditure is $65. So although their income level is higher, but their consumption is lower than at least two of those families who are earning less than that. The point that I'm trying to make is that at multiple points in this graph, you would see that although the income has increased, but the consumption is lower than the consumption of some of the families in the previous lower income bracket. So if you want to make some sort of overall judgment, what happens to consumption expenditure when income is increasing, then for some families, it's quite absolutely correct that as income increases, their consumption expenditure is also increasing. But for some families, it is actually the opposite. Like, for example, as income increases, then the consumption expenditure of some families here is lower than the consumption of some families in the previous lower income group. So therefore, if we focus on the individual Y values, then we are not able to get a proper conclusion whether when X increases, Y is actually increasing or decreasing, right? So then we say that rather than looking at the individual Y values, which are represented by the small dots in this graph, if you plot the values in the last row of this table, right? If you plot the values in the last row of this table corresponding to the values in the top row. So rather than plotting individual Y values corresponding to these X, if you plot the conditional mean values corresponding to X, so that has been depicted by the bigger dots. So these bigger dots represent what? The values in the last row of that table, which we call the conditional mean, whose statistical symbol is expected value of Y given X, conditional mean of Y. So if these bigger dots represent 65, 77, and so on, which you saw in the last row of that table. So if we focus on, if we plot the values in the last row of that table corresponding to these X values, and then connect them with a straight line, now the situation is quite clear, right? You see, it's clearly forming a straight line, and now it's quite clear that as X increases from 80 to 260, what is happening to the conditional mean of Y? Rather than individual values of Y, for which at some places there was increase, while at some places there was actually a decrease. If we now focus on relating the conditional mean of Y with X, we can see a clear straight line. And now we can say that as X increases, then the average value of Y is increasing. This particular conclusion that I have just told you, this forms the fundamental idea behind regression model, right? So all the regression models, and I'm just slowly repeating this thing, so clearly listen to what I'm saying. All the econometric models that we are going to consider from this point onward, they will be basically relating our explanatory variable, in this case, for example, weekly income, with the conditional mean of our dependent variable, right? So when you are talking about regression models or econometric models, what we are doing actually, we are not relating the individual values of Y with our X, rather we are relating the conditional mean values of Y with our X. Why? I have already told you the logic right now, that if you relate the individual Y values with X, you are not going to get a clear idea about the relationship between Y and X. But when you relate the conditional mean of Y with X, you see, you get a clear straight line. It's not necessary that you always get a straight line. This is just a hypothetical example. So that's why you are getting a straight line. But at least this straight line is telling you that relating conditional mean of Y with X gives you a much clearer picture of relationship between a dependent variable Y and X. So therefore, in a nutshell, I would say that if you want to study relationship between Y and X using the data that you can see on the slide right now, the reasonable approach would be that don't relate the top row of this table, which represent X, with the values in the middle, which represent what? Individual Y values. Rather, what you should do, you should relate the top row of table 2.1 with the bottom row of table 2.1. So this particular thing that I'm telling you right now, this forms the basis of all regression models, okay? Whether we are talking about simple models on which we are focusing in the beginning, or when we'll be going for more complex models, cross-sectional models, time series models, and later on panel data models, this basic fact will remain intact, right? So that's why I'm telling, although this seems to be a very simple point, maybe for some of the participants, this would be a very simple point, but as I'm telling you most of the time, and I will be telling you most of the time, that most of the time, simple points are actually very important points, right? So this is one example of such instance where the point is simple, but fundamentally very important for all our discussion later on. So the conclusion is that when you talk about regression models, irrespective of any type of regression model or econometric model that we'll be considering, you should always relate X not with the individual Y values, but actually with the conditional mean of the Y values. Or in simple words, relating the top row with the bottom row. So therefore, this would be actually our fundamental point. And this would become clear as we move forward. लेकिन ये मैं आपको इसलिए कह रहा हूँ कि keep in mind this table 2.1, because sometimes I will be just referring you back to this table जहाँ पे conceptual clarity की ज़रूरत हो. So I would say, okay, just go back and recall table 2.1 so that we get connected with the basic idea of regression analysis. All right. Okay, let's move to one more point. Is it okay till now? Hello?
Yes, sir. It's okay, sir.
Okay, right. This line, this particular line that you can see right now, which actually represent the graph relating X and Y. लेकिन ये relationship वो किस तरह कर रहा है? Relating X with the conditional mean of Y. This line is also having a particular name, जिसको in a long run कोई particular याद रखने की जरूरत नहीं है, but for the first time, if you just look at the name of that line, we call this line the PRL, population regression line. Why we call it population regression line? Because this represents relationship between our dependent variable and our explanatory variable in the whole population. क्योंकि अभी मैंने आपको ये बताया कि we consider this table 2.1 is representing a population of 60 families. Although real life में population 60 families का नहीं होता, it's much bigger than 60 families, but just for the purpose of concept, we say consider it a population. So this is called PRL, population regression line. Although later on you will discover that because we will not be dealing with population data, so this PRL will remain unknown. ये हमें पता नहीं होगा कि PRL का nature क्या है, right? We will be studying this PRL through a sample regression line, जिसको हम बाद में कहेंगे SRL, sample regression line. But anyhow, this is just the name given to this graph. और इस केस में ये ग्राफ क्या है? Straight line. As I have already told you, this graph in the given case is a straight line. Again, जिस तरह मैंने आपको last lecture में कहा था, it's not necessary that the relationship between y and x is always a straight line. लेकिन इस केस में तो at least we are sure that it is a straight line. Okay. Now, the next concept, which is fundamental to our regression modeling, is what we call the PRF. PRF stands for population regression function. Population regression function, right? और नाम भी हैं जिस तरह, for example, conditional expectation function, लेकिन आप इसको छोड़ दें. फिलहाल अगर ये आप याद रखें तो it's okay. From the preceding discussion and the figure, it is clear that each conditional mean expected value of y given x is a function of x, right? If you look at this particular graph, so we can see that this mean value of y, जिसको हम कहते हैं conditional mean of y, this depends on what? This depends on x. Mathematically, we say that this conditional mean of y is a function of x. Why it's a function of x? Because when x is 80, then conditional mean of y is 65. ये देखें? When x is 80, then conditional mean of y is 65. But when x becomes 100, what is the value of this conditional mean? It is 77. And so on. So as x changes, the value of this conditional mean is also changing. So mathematically, हम क्या कहते हैं? We say that this conditional mean is a function of x. Function of x means it depends on the value of x. So symbolically, we write it like this. As you can see at the top of this slide, expected value of y given x, which we call the conditional mean, the last row of table 2.1. So the values in the last row of table 2.1 is basically a function of x, f of x, right? As I have just explained, why we say it is a function of x, because if x is 80, then you have one value of this conditional mean, but when x becomes 100, then you have another, and so on and so forth. So this particular mathematical form, that you can see at the top of this slide, this is actually given the name of PRF. So what is PRF? PRF is just the mathematical form of PRL, right? If you want to represent the graph that you saw just a little while ago, this graph, which represents relationship between conditional mean and x, if you want to represent this graph mathematically using equation rather than graph, आपको पता है ना graph की limitations होती हैं. So therefore, you cannot just have graph for each and every possible situation. So this graph, if you want to represent it mathematically, so we can represent mathematically it like this. We can say that expected value of y given x is f of x. And the name given to this is PRF, population regression function. So in simple words, what is PRF? PRF is just the mathematical representation of the PRL, population regression line. Now the question is, which f of x you should use here? Which f of x you should use here? Now, if you look at the graph, in the given instance, we have absolutely no doubt that this graph represents what? A straight line. And we know from our previous knowledge what is the equation for a straight line. So in the given case, we know what should be f of x. That is the reason why you can see that the functional form of the PRF can be written as beta 1 plus beta 2 xi. Okay, it can be written as beta 1 plus beta 2 xi. So f of xi has been written in this particular form. In the given case, it was possible to write this thing as beta 1 plus beta 2 xi because we have just looked at the graph and it's very clear that this f of x should be the equation of a straight line. Although we would not be that much lucky later on to always have exact knowledge about f of x, but I would have some discussion जिसमें मैं आपको ये बताऊंगा कि even if you don't know what should be the possible f of x, what should be the functional form of that, you should start with a straight line. Okay, you should start with this even if you don't know what is the actual f of x, because this is the simple possible consideration that you can take. But in the given case, there is no doubt that this f of x can be taken as this. So therefore, if we want to represent this graph, जिसको हम कहते हैं PRL, if you want to represent this graph in mathematical form, what would be that mathematical form? It would be, as you can see at the end of this slide, expected value of y given x equal to beta 1 plus beta 2 xi, okay, which is the equation of straight line where beta 1 represent the intercept and beta 2 represent the slope. And as would become clear from our discussion later on, right, this expression that you can see right now on the screen, the last one, जिसको हम कहते हैं PRF, this basically becomes the population regression function. This basically becomes the regression model for the whole population. Because this regression function would be unknown if you are not dealing with the population data. So therefore, you have to estimate this PRF. As long as we are dealing with the population data, we would be actually trying to use this particular equation for describing relationship between our y variable and x variable. But as would become clear from our discussion, because in real life, we are not usually dealing with the whole population, rather we are dealing with sample data. So remember, this PRF would remain unknown, and we have to approximate it by the sample data. And as you will discover, when you are using the sample data to estimate this PRF, we will simply replace this P with S, and then we will be using the terminology of SRF, sample regression function. And as I will tell you, just wait for some further slides, and I will just tell you that when you replace this P of the PRF by S and you call it SRF, so SRF would be nothing but a sample version of this particular expression that you call the PRF. So PRF represents the relationship between our dependent variable y and independent variable x in the population, while what we would call SRF in a short moment, that would represent the same relationship, but based on sample data rather than population data. And you know that in usual life research problems, we deal with sample data rather than population data, because you know from your previous knowledge that because of multiple reasons, it would be either impossible or very difficult to study the whole population. So that would be the reason why you will be going for a sample rather than for a population. So as long as you are dealing with sample data, remember this relationship between the y and x variable, which you represent in the form of PRF, this would remain unknown. And the rest of the story that we would have in this whole course would be, how can you estimate an appropriate PRF through sample data? I mean, what would be an appropriate SRF for this PRF? That would be the whole thing that we'll be learning, and what sort of SRFs are available, because if you recall, I have already told you that regression models or econometric models that we will consider, apart from other things, it also depends on what? On the nature of data. Like if you're using cross-sectional data, then you would have one type of econometric model. If you're dealing with time series data, then you would have a different type of econometric model. But these ideas that I'm describing right now would remain unchanged. Like, for example, when I'm talking about the PRF, and later on, I will be talking about the sample version of this PRF that I will call SRF, the idea will remain the same. The functional form of the model may change, but the basic idea will remain intact. So that's why I'm taking a little bit time to explain these concepts right now, because later on I may not be spending that much time on these ideas. So that's why it's better to cover all these things right now. So PRF is the fundamental thing. The other thing that I would like to clarify, why we consider the PRF rather than the graph, I hope most of you are already convinced. In many cases, either we cannot draw the graph, right? As I would explain, when we move from simple regression situation to multiple regression, like for example, in the given case, we are talking about dependence of our y variable on just one x variable. This is what we call later on the simple regression model. When we would move by considering more than one x variable, like we would have x1, x2, and so on, you would see that the graph that you would like to get would not be that much straightforward. So you cannot just talk about the possible relationship of our y variable with more than one x variable by just looking at the graph. And also graph has got another limitation that I will explain in our next lectures. So therefore, in order to study relationship between our dependent variable y and independent variable x, and later on multiple independent variables x1, x2, and so on, our main concern would be to consider an appropriate PRF and approximate that PRF by an appropriate SRF, sample regression function, and then try to make, in a sense, interpretation of that. Okay. I don't know whether I have discussed the idea of linearity in our previous lecture or not. Can somebody tell me कि ये linearity का idea हमने discuss किया था last lecture में? Hello?
नहीं सर, नहीं किया linearity सर.
Okay, okay. Okay, how much time we have? Just let me check it out. Okay, should we continue? Is it okay? Or should we stop here? Hello?
जी सर.
Sir, should we continue?
जी, okay, all right. Okay, आपके इसके बाद कोई और लेक्चर तो नहीं है ना आपका?
बिल्कुल कंटिन्यू कर ले सर. नो सर, कोई
नहीं,
lecture
सिर्फ कंसर्न मेरा ये है कि आई हैव नो प्रॉब्लम इफ यू हैव नो प्रॉब्लम, ठीक है, लेकिन असल में इफ अनदर टीचर इज वेटिंग तो फिर हम नहीं कर सकते ना. इस कोई और लेक्चर अगर आपका ना हो सो यू जस्ट कंटिन्यू. ओके
सर, कंटिन्यू कर ले.
all right. Okay, so let's move to the slide again. Okay, so
एक्सक्यूज मी सर.
जी
सर ये जो आपने SRF और सिंपल रेग्रेशन फंक्शन, जी सर CRF, सर इसका थोड़ा सा एक दूसरा वो दे दे आप एग्जांपल थोड़ा सा इसके, क्योंकि बेसिक है ना सर, तो सब समझ आ गई मगर इसमें थोड़ा सा कंफ्यूजन हो रही है सर.
I mean, in a sense, should I repeat quickly what I have just said? आप ये कह रहे हैं?
सर एक तो सर इसमें है ना, आपने कहा कि पॉपुलेशन मीन का जो है ना एक्सपेक्टेड वैल्यू ऑफ जो मीन है y का, जो x पर जो हमारा एक्सप्लेन वेरिएबल जो है ना उसको हम करते हैं सर. इसमें जो सिंपल सर, इसमें एक आपने कहा कि PRF है ना सर, एक सिंपल SRF है सर, उसमें थोड़ा सा कंफ्यूजन सर हो रहा है मुझे.
हाँ, नहीं, वो SRF चूंकि मैंने अभी इंट्रोड्यूस नहीं किया है ना, तो इसलिए मैं उसके डिटेल्स में नहीं जा रहा हूँ. मैंने कहने का सिर्फ मकसद ये था, आपको ये स्क्रीन नजर आ रहा है अभी ना?
सर
ठीक है, क्योंकि फॉर द टाइम बीइंग आई हैव जस्ट इंट्रोड्यूस द टर्मिनोलॉजी PRF, ठीक है, और PRF को मैंने इस तरह कहा था कि PRF इज सिंपली द मैथमेटिकल फॉर्म ऑफ द PRL. ये जो ग्राफ आपने देखा ना, ये वाला
स्ट्रेट लाइन, बिल्कुल सर,
व्हिच इज बेस्ड ऑन द डेटा ऑफ टेबल 2.1, ठीक है ना. ये सारे कनेक्टेड चीजें हैं जो मैं डिस्कस कर रहा हूँ. टेबल 2.1 में मैंने आपको ये कहा कि in order to give a better understanding of relationship between x and y, you should relate the last row, जिसको हम कहते हैं conditional mean, with the top row, right? तो आपको ये सिचुएशन ज्यादा क्लियर आ जाती है. सो इस ग्राफ को मैंने नाम दिया PRL, population regression line. And then I say, what is PRF? PRF is just the mathematical representation of the same graph, right? If you want to, if you want to represent this graph, which actually shows relationship between y and x, लेकिन ये हमेशा याद रखें कि when I'm talking about relating y with x, I'm not relating the individual values of y with x. I'm relating the conditional mean. I hope that most of you are not clear when I use the terminology conditional mean. ये तो clear है आपको ना?
Exact sir.
So therefore, whenever I use the word conditional mean, you should all be clear what I'm talking about, right? Always keep this table 2.1 in mind, और last row को recall करें तो आपको immediately understand हो जाएगा कि what I'm talking about. So expected value of y given x is actually talking about these conditional mean. So we said that the better approach would be to relate the conditional mean with x. And that would give you a clear pattern. And then we said, how can you mathematically express this graph? So the mathematical representation of this graph को हम कहते हैं PRL, population regression line, और इसके mathematical expression को हम कहते हैं PRF. So mathematically, PRF is represented like this: expected value of y given x, which means conditional mean equal to f of xi. It's a function of xi. तो ये बेसिक डेफिनेशन है PRF की. फिर हम ये कहते हैं कि गिवन केस में ये PRF क्या हो सकता है, यानी इन अ सेंस व्हाट कैन बी द राइट हैंड साइड ऑफ PRF. सो इन द गिवन केस वी हैव नो डाउट, अगर हम इस ग्राफ को देखें, सो वी हैव नो डाउट दैट दिस रिप्रेजेंट अ स्ट्रेट लाइन. और वो हमारे प्रीवियस नॉलेज से हमें पता है कि व्हाट इज द इक्वेशन फॉर अ स्ट्रेट लाइन. इट इज समथिंग लाइक a plus bx. ये तो आपको पता है ना, सिर्फ नोटेशन यहाँ पे डिफरेंट है. A की जगह बीटा 1 ले लें और B की जगह बीटा 2 ले लें. So this is simply like A plus BX. So in the given case, f of x is beta 1 plus beta 2x. So this represents a straight line relationship. So therefore, the relationship between the conditional mean of y and x is actually a straight line relationship. और ये मैंने आप ये कहा कि for the time being, we start with a straight line relationship, although it's not necessary that it's always a straight line later on. लेकिन फिर मैंने आपको ये कहा कि very soon I will introduce another terminology जिसको मैंने introduce नहीं किया है. I am really sorry कि अगर आप confuse हो गए. फिलहाल मैंने सिर्फ PRF को introduce किया था. कहने का मकसद सिर्फ मेरा ये था कि because this PRF represents the relationship or the equation when you are dealing with the whole population, right? But in real life, you know, in real research, we are usually not dealing with population data. We are dealing with sample data. So naturally, if you are not dealing with population data, this PRF would no more be visible. यानी इसको आप estimate नहीं कर सकते. So then I said that very soon you will discover that we will consider a sample version of the PRF, a sample version of this equation. और उस sample version of this equation को मैं फिर नाम दूंगा SRF, right? Whatever that looks like, फिलहाल मैंने इसको introduce नहीं किया है कि how SRF looks like. लेकिन सिर्फ मैंने आपको ये कहा है कि if this is PRF, then there would be another thing that I will be using, I will be calling SRF, sample regression function. और sample regression function का purpose सिर्फ ये होगा कि how can I estimate this equation जिसको मैं सिर्फ population data के लिए estimate कर सकता हूँ. How can I estimate this equation if I am dealing with sample data rather than population data, right? So SRF would later on become our main focus of attention. But remember, even if we are talking about SRF later on, our main focus of attention will remain the PRF. Okay? Because you know from your previous knowledge, that whenever we are using sample data, our main interest remains in the population. Yani we are always interested in the bigger picture. ये जो smaller picture होता है ना जिसको हम sample कहते हैं. We are studying sample only to study the population. Sample का और कोई purpose नहीं होता. उसका purpose क्या होता है? To generalize, to say something about the actual picture. So the same would be the case when I will be later on introducing SRF. But whatever is SRF, फिलहाल चूंकि मैंने उसको show नहीं किया है तो forget about के how it looks like. But what I am saying that in order to study PRF in case of sample data, there would be another function that we would be calling SRF. That SRF would be just the sample counterpart of the PRF. How it looks like, वो तो मैंने आपको show करना है ना कि how it looks like. But I mean, सिर्फ कहने का मकसद ये था कि if you were dealing with population data, then it would be most of the time very easy to get what we call the PRF. But very soon you will discover that because PRF would not be able to, you would not be able to obtain PRF because of simple fact that you are not dealing with population, right? So therefore, then we'll be talking about the SRF. अब वो SRF किस फॉर्म में होता है? वो तो
सर ये PRF में सर ये बीटा 1 हमारे पास सर इंटरसेप्ट शो कर रहा है.
Exactly.
और सर बीटा 2 सर हमारे पास स्लोप आपको.
Exactly.
Okay, sir.
हाँ, in the given case हम इसको ये नाम इसलिए दे रहे हैं because we know that it represents equation of a straight line. So beta 1 is representing the point at which this line would intersect. It will touch the y-axis. It will cross the y-axis. Or beta 2 is just representing the steepness of this line, how much steeper or flatter this line is, right? जिसको last lecture में मैंने आपको ये कहा था ना कि it represents del y by del x. ये तो आपको बताया था मेरा ख्याल है shortly, या नहीं बताया था?
सर पता है सर.
थोड़ा सा आइडिया हमने डिस्कस किया था ना. Although उसको उसके कुछ और explanations तो भी रहती हैं, लेकिन फिलहाल हमने उसके fundamentals डिस्कस किए थे कि beta 2, which is the coefficient of the variable x, represent the slope, and very soon you will discover that actually we will be talking about studying relationship between y variable and x variable. This beta 2, the coefficient of the x variable, would play a very important role in that. यानी जो हमारा research question होगा later on ना, कि what is the effect of x on y? The nature of beta 2 would actually play a very important role over there, whether it's estimation, whether it's hypothesis testing, a number of other things. Beta 1 would also have its role, like an important role. Kiska hoga? Beta 2 ka hoga. What I'm trying to tell you right now, that the f of x, the right hand side of the PRF that you are observing right now on the screen, this is just one possibility in the given case. Later on, you will see a number of other possibilities for f of x. यानी कहने का मकसद फिलहाल ये है कि f of x may not always be in this simple form, right? But how can you decide a proper f of x in a given situation? इसको हम ज़रा detail से discuss करेंगे. So therefore, if you are not that much clear about how can we just decide on f of x, don't think too much for the time being, because this will become clear as we move forward. लेकिन फिलहाल हमारे लिए choice इसलिए easy था कि because we just looked at the graph and we discovered that it is a straight line. So therefore, it was a very simple option. Later on, it may not become a simple option, but even in that case, we will actually start with this simple option. The next point that I'm trying to make is what we call the meaning of linearity, because our discussion would be based on linear regression models, right? Linear regression models. Like we will be using the word simple linear regression model, then you will be hearing from me multiple linear regression models. So now let us quickly clarify what we mean by the word linear in the context of regression models. So when you are using the word linear, it can represent two situations. We can be talking about linearity in variables, or we can be talking about linearity in parameters. अच्छा, ये जो आप f of x है ना, इसमें parameters हम किसको कहते हैं? ये betas. Betas represent the parameters, जिसको बाद में हम कहेंगे regression coefficients. And the variable is actually this x. Later on, we will be adding a number of other variables. Like फिलहाल तो सिर्फ एक x variable है ना. Very soon we will be adding x1, x2, x3, and so on. So in the given case, in the given PRF, we have one variable x on the right hand side, and we have two parameters betas. So when you are using the word linearity, linearity in variables mean that the highest degree of the variable is 1. The highest degree of the variable is 1. So for example, if you look at this expression on the slide right now, the highest degree, the highest power of the variable x in the given expression is 1. So we would say that this particular model, this particular equation which represents a model, this is linear in the variable x, right? This is linear in the variable x. Why I'm saying this is linear in x? Because x has a highest power of 1. It is neither less than 1, it is neither more than 1, right? But if it is something like this, as you can see here, if the expression is beta 1 plus beta 2 x square, then the highest power of x is other than 1. So we would say that this model, this PRF, is non-linear, but it is non-linear in x, non-linear in variable. So we would say that this model is non-linear in the variable. But if you look at the betas, the highest power of betas is still 1. So we would say that this model that you can see on the screen right now, this is linear in parameters, but non-linear in variables. While the expression that you saw on the previous slide, this one, the highest power of the betas is 1, and the highest power of the x is also 1. So we would say that this one is linear in both. It is linear in parameters as well as variable. But if you look at the expression here, when you say beta 1 plus beta 2 x square, then this is linear in parameters, but it is non-linear in variables. But if you look at something like this, now look at the top over here. Now here x is with the highest power of 1, but one of the parameters has a power other than 1. इस केस में 2 है, किसी और केस में वो क्यूब भी हो सकता है, या log हो सकता है, या reciprocal हो सकता है, right? As long as the power is other than 1, we say it shows non-linearity. So in this case, variable has a highest degree of 1. So we would say that this model is linear in variable. But because one of the parameter has a power other than 1, so we would say that this model is actually non-linear in parameters, right? If both or at least one of the parameter has a degree other than 1, then we would say it is non-linear in parameters. ये भी हो सकता है, for example, अगर इसमें आप x square ले लें, या x cube ले लें, या log x ले लें, या 1 over x ले लें, so then we would say that it represents a model which is not only non-linear in parameters, but also non-linear in variables. So to make it short, look at this table that you can see at the end of this slide. This is just a 2x2 table. We just summarize the whole situation. But look at this statement. If you want to decide when a model, a regression model will be declared as a linear regression model, we say that from now on, the term linear regression will always mean a regression that is linear in the parameters, which means the highest degree of the betas is 1. Just to understand, look at the table below. This is a 2x2 table. Model linear in parameters, yes or no? The model can be linear in parameters, which means all the betas are occurring with the highest power of 1. So the answer would be yes. Or model is non-linear in parameters, which means that one of the parameter has a power other than 1. So model linear in parameters, 2 possibilities, yes and no. Similarly, there are 2 possibilities for variables. The model can be linear in variables, yes, or it can be non-linear in variables, which means if one of the variable, in the given case only one variable is there, if the variable has a highest power other than 1, so it would be no. So the combination of yes and yes, right? If the model is linear in parameters, yes, and it is also linear in variables, yes, then the model will be declared as LRM. This is a situation like this. You see, ये जो जहाँ से हमने start लिया था, when you look at the functional form of the PRF, here, the highest degree of the parameter is 1, as well as that of the variable is 1. So we would say that this is representing a model which is linear not only in parameters, but also in variables. So if that is the situation, then you say that the model will be called LRM, linear regression model. If the model is linear in parameters, but non-linear in variables, right? A situation like this, as you can see here, the highest degree of betas is 1, but the highest degree of x is not 1, it is other than 1. This represents a situation of yes for parameters and no for variables. But according to regression theory, the model would still be called LRM, linear regression model. If the model is non-linear in parameters, which means if it is no here, then irrespective of whether it is linear in variables, yes, or non-linear in variables, in both cases, the model will be declared as NLRM, non-linear regression model. So therefore, linearity of the model would simply mean that it should be linear in parameters, right? So therefore, from now on, when we'll be using the word linear regression model, for example, simple linear regression model, multiple linear regression model, by that we would actually mean that we are talking about a model in which all the betas are occurring with the highest degree of 1, right? It doesn't mean that the regression model cannot be nonlinear. Of course, you can talk about nonlinear regression model, NLRM. But usually when we talk about the regression models, the type of econometric models that we will be considering in this course, the usual models are actually LRM, linear regression models. One of the reasons is that linear regression models are simple, results are more established, mathematically a little bit less complex. Nonlinear regression models are more complicated, mathematical theory is more rigorous, right? So as long as we can use the linear regression model, we would not go for the non-linear regression model. Later on, I would also have some discussion, but I mean from this slide onward, I just want to make it clear that when we use the word linear regression model, what we mean by linearity. So linearity would mean linearity in parameters. Okay, is it clear?
Yes, sir.
All right. All right. There are some discussion of the meaning of the disturbance term in the model. Although I'm not going to discuss all these things in detail, the reason was just to show you the slides. This slide and the next two slides are actually telling you what this disturbance term represent in our regression model. I mean, why there is a justification for. So we had some initial discussion of the error term in our previous lecture. So I just want to just go and study, just give it a reading, that there can be multiple explanations why the disturbance term is included in our model, like vagueness of theory, unavailability of data, core variables versus peripheral variables, intrinsic randomness, poor proxy variables, principle of parsimony, wrong functional form, etc. Right? These are some of the reasons that would actually justify. एक मैंने आपको last lecture में एक simple justification दी थी कि even if you don't specifically say that it may represent vagueness of theory, it may represent unavailability of data, one simple justification for the disturbance term or the error term in our model is that it represents, in a sense, all those excluded explanatory variables that can possibly affect our y variable, right? So आप इसको इस तरह भी कर सकते हैं, लेकिन this is some further explanation that I was actually trying to show you. तो इसको जरा सा एक reading दे दें. If there is any confusion, we can discuss it in one of the other lectures. Okay.
सर ये रीजन अगर थोड़ा सा शॉर्ट एक्सप्लेन करे तो
चलें, ठीक है, मैं बता देता हूँ. Most of them are actually self-explanatory. अगर आप इसको एक रीडिंग देख लेंगे, मैं आपको क्विकली बता देता हूँ. Apart from that main reason, जो कि I hope आप सबको clear है ना कि disturbance term represent all those other known or unknown factors which can possibly affect our our dependent variable. Vagueness of theory, the theory, if any, determining the behavior of y may be and often is incomplete. We might be ignorant or unsure about the other variables affecting y. Okay, so this is exactly the same point that I have just said. Like, for example, sometimes the theory that you are using may be vague. Any simple example, मैं आपको ये बताता हूँ कि if you just look at the Kinesian theory of consumption. Kinesian theory of consumption, for example, it may not necessarily be this theory, like just for the sake of example, मैं बताता हूँ कि it is talking about what happens to consumption when income increases, right? So it is not specifically telling you about all other possible factors which can also affect consumption behavior of the families. So therefore, if theory is not very clear about the possible nature of our dependent variable, so you can say that this disturbance term can also cover or stand for any vagueness in the theory. अगर theory में कोई clarity नहीं है, so it can adjust that theory for that vagueness. इसको हम कहते हैं कि disturbance term may represent the vagueness or the non-clarity in theory. So it may represent some of the other factors which theory is not describing. तो ये disturbance term की एक justification होगी. Unavailability of data is also one possibility. Like for example, as a researcher, you have decided that you want to study a phenomena, और फिर आपने using the literature or using your own knowledge, आपने decide किया है कि I would consider, for example, this list of explanatory variable in my model, right? आप कहते हैं कि जी ये 10 variables हैं जिसको मैंने as explanatory variables use करना है अपने model में. तो next step क्या होगा? When you mention or specify your econometric model, next step data collection होगा ना, right? So you say, okay, let me just go and collect data on my y variable and on these 10 explanatory variables. And then you discover that unfortunately, the data on one or more explanatory variable is not available. जिस तरह आप कॉमन रिस्पोंडेंट सर्वे में देखते हैं ना कि आप कोई ऐसा क्वेश्चन पूछते हैं जिस पे बाज रिस्पोंडेंट्स आपको आंसर नहीं देते, या वो क्वेश्चन बड़ा सेंसिटिव होता है, राइट? तो वो या तो आंसर देते नहीं या रॉन्ग आंसर देते हैं, और या वो सिंपली रिफ्यूज कर देते हैं, या वो क्वेश्चन जो आपने लिटरेचर से फॉर एग्जांपल एक वेरिएबल आइडेंटिफाई किया है, द डेटा ऑन दैट पर्टिकुलर वेरिएबल वाज अवेलेबल इन अदर country, but in your country somehow the data cannot be collected. तो आप क्या करेंगे? उस वेरिएबल को अपने मॉडल में इंक्लूड तो नहीं कर सकते ना. So you have to drop that variable from your model, right? So therefore, if the data on some variable or variables cannot be available, you can make a sort of adjustment in your model, and that adjustment would be represented by what? It will be represented by the disturbance term, the error term. Core variables or peripheral variables का भी वो concept है कि, for example, in case of consumption and expenditure, you know that apart from income, there are also other variables, like, for example, number of children per family, sex, which means sex of the head of household, religion of the respondent, education of the respondent, geographical region in which the respondent or family is living. These also affect consumption expenditure. But somehow, if you discover that the effect of, for example, income is such that, यानी चलें इसको मैं इस तरह describe कर देता हूँ कि although you know that there are other variables which can also affect your dependent variable, but somehow you have this feeling that the joint effect of all those variables is not that much as compared to one or two variables that you want to include in your model. तो ये जिन variables जो आपके ख्याल में ज्यादा pronounced effect represent करते हैं, उसको हम कहते हैं core variables. Core variables are those variables which you have to consider for your model. Peripheral variables are those variables which have some effect on your y variable, but that effect is not that much. यानी बहुत small है. तो आप ये कहते हैं कि if I drop those other variables, जिसको हम peripheral variables कहते हैं, my model would not be that much. It means I would not be losing that much information if I drop some of the variables from my model, so that my model become a little bit more comprehensive, more compact. तो ये जो error term होगा, it may represent those dropped variables, those peripheral variables. So the usual models that you use in your research, usually it does not include all possible independent variables. ठीक है? उसका रीजन ये होता है कि उसमें से कुछ कोर वेरिएबल्स होते हैं जिनको आपने हर हाल में कंसिडर करना है, बिकॉज लिटरेचर से आप कन्विंस्ड हैं कि दीज वेरिएबल्स मस्ट बी कंसिडर्ड. लेकिन कुछ और वेरिएबल्स भी होते हैं जिसके मुतालिक आपको पता होता है कि मे बी दे आल्सो हैव सम इफेक्ट, बट द इफेक्ट इज सो स्मॉल दैट आई कैन सेफली इग्नोर देम. बट इसका मतलब ये नहीं होता कि उनका इफेक्ट जीरो होता है. So therefore this error term can possibly stand for those. Intrinsic randomness in human behavior का मतलब ये होता है कि even if you account for all possible factors, यानी theoretically आप assume कर लें कि you consider all those relevant explanatory variables that you want to consider in your model, there is something called intrinsic randomness in individual behavior. ये जो as a human being, we are all different, right? Whether it's a family or whether it's an individual person, we don't, in a sense, react in a similar fashion in all situations. Even if in the same circumstances, like for example, if you go to shopping in a bazaar, you know that even if all people have got the same level of income, they have, in a sense, the same gender, they have got the same similar interest, for example, it's not necessary that they will be spending exactly the same amount in the bazaar, right? Why? Because as human being, there is an internal variation. There is something which makes you different from other persons. This is called intrinsic human behavior. तो अगर और कोई भी रीजन ना हो तो ये जो इंट्रिंसिक ह्यूमन बिहेवियर में वेरिएशंस हैं, इसको एडजस्ट करने के लिए फिर आप क्या करते हैं? यू यूज द एरर टर्म, द डिस्टर्बेंस टर्म. पुअर प्रॉक्सी वेरिएबल का मतलब ये होता है कि समटाइम्स you want to use a variable, लेकिन that variable cannot be properly measured. So what you do, rather than using the actual variable, you use a variable which is very much closer to that variable. यानी for example यहाँ पे example given है कि if we want to study relationship between let's say income and consumption, right? या अगर हम फ्रीडमैन्स की थ्योरी को वेरीफाई करना चाहते हैं, so Friedman's theory is basically based on permanent consumption and permanent income. But in real life, it's almost impossible to get data on permanent consumption and permanent income. So हम क्या कहते हैं कि rather than collecting data on permanent consumption and permanent income, what is actually possible is to collect data on current consumption and current income. But you know that current consumption is not exactly the same as permanent consumption, and current income is not exactly the same as permanent income, right? But they closely represent those ideas. So we say that because of our inability to collect data on permanent consumption and permanent income, we collect data on current consumption and current income. So current consumption is considered as a proxy for permanent consumption, and current income is used as a proxy for the permanent income. The difference between these two is what we call the measurement error, right? जब एक वेरिएबल को आप किसी दूसरे क्लोजर वेरिएबल से मेजर करते हैं जो कि उस वेरिएबल को एग्जैक्टली रिप्रेजेंट नहीं करता, तो इसको हम क्या कहते हैं? Measurement error. So we say that this disturbance term can actually represent the measurement error in variables, right? Principle of parsimony actually says that when you will be deciding which model you want to use, so later on देखेंगे कि we would have option for using different models. We can use a very complex model for our research hypothesis, for our research, or we can use a simple model. One meaning of simple, ये इसका explanation तो बहुत ज़्यादा हो सकता है कि what we mean by simple model and what we mean by complex model. लेकिन फिलहाल just to explain the point, we say that one meaning of simple versus complex model would be that simple model would be that in which the number of explanatory variables are comparatively smaller. जैसा सिंपल रिग्रेशन मॉडल है ना जिसमें एक x वेरिएबल होता है, राइट, और एक दूसरा मॉडल है जिसमें 10 एक्सप्लेनेटरी वेरिएबल्स हैं, तो हम कहेंगे कि द मॉडल इन विच द नंबर ऑफ एक्सप्लेनेटरी वेरिएबल्स आर स्मॉलर इन नंबर would be considered as a simple model, as compared to a model in which the number of explanatory variables are quite large. So later on, we may discover that sometimes a simple model may give us almost the same information as would be given by a very complex model. So principle of parsimony actually tell you, principle of parsimony means principle of simplicity, right? Parsimony means simplicity. So principle of parsimony says that if you can describe something with a simple model, why should you just go for a very complex model? Later on, हम discuss करेंगे why there would be a problem if you are dealing with complex model, because complex model में बहुत सारे issues हैं जो कि as we move forward मैं आपको फिर explain करूँगा कि for example what sort of issues you can have when you are dealing with a complex model. So principle of parsimony says the simple the better, right? If you have a choice between a simple model and a complex model, subject to the condition that the amount of information provided by both are almost the same. यानी simple model आपको almost वही information दे रहा है, exact तो नहीं लेकिन almost, which the very complex model, like a very large model, is actually giving you. So principle of parsimony says that go for the simple one rather than the complex one. So ये जो आप replacement करते हैं, क्योंकि exact information हो सकते हैं आपको एक complex model ने देना था, but what you do rather than a very complex model which can give you the exact information, if you use a simple model which can give you almost the same information, so this loss of information जो कि आपको obtain होगा by using a simple model, this would be represented by the error term, right? So in order to use the principle of parsimony, this error term can give you the justification. वो आपको कहता है कि okay, go for the simple model, whatever is the adjustment that would be taken care by the error term. So this is actually what we call the principle of parsimony. Wrong functional form का मतलब ये होता है कि for example you should have used one particular mathematical form of f of x. ये जो मैंने आपको शुरू में कहा ना कि for example we are taking f of x as the straight line, उस वक्त मैंने आपको कहा था तो तकरीबन ये पॉइंट मेरे जहन में था कि it's not necessary that the relationship between y and x is always a straight line, right? हो सकता है उनके दरमियान relationship parabolic form में हो, वो exponential form में हो, लेकिन somehow या simplicity purpose के लिए या for example you have no particular idea, you just take f of x as let's say a straight line, while actually it's not a straight line. तो इसको हम कहते हैं कि misspecification, यानी आपने wrong functional form लिया है, यानी उसका functional form एक होना चाहिए था लेकिन आपने क्या किया है, आपने उसको किसी और form में लिया है, right? So this error term can also make for that adjustment, that sort of error which you are making when you take the wrong functional form, right? So for example, if your right functional form was that you should have used only x in your model, right? लेकिन आप उसकी जगह कोई और ले लेते हैं, जिस तरह फॉर एग्जांपल आप इस गिवन केस में आपको एक्चुअली एक्स स्क्वायर इंक्लूड करना चाहिए था, लेकिन आप एक्स स्क्वायर को इंक्लूड नहीं करते बिकॉज यू हैव अ लैक ऑफ नॉलेज अबाउट दैट, और आप सिर्फ एक्स को इंक्लूड करते हैं. सो वी वुड से that these two represent two different functional forms. तो अगर आपके पास एक को यूज करना चाहिए था and you use the other one, then we say that you are using the wrong functional form, right? Later on हम discuss करेंगे कि for example what is the importance of a correct functional form and why it is difficult to decide a proper functional form. लेकिन फिलहाल हम ये कहते हैं कि if you use a functional form which is not the right one, so error term can also be considered as sort of adjustment for the functional form, the wrong functional form. Okay, so these are some of the reasons. लेकिन अगर आप इन तमाम डिस्कशन को देख लें तो आपको बेसिकली आपको एक ओवरऑल कंक्लूजन वही आता है जो मैंने आपको शुरू में कहा था कि दिस एक्चुअली स्टैंड्स फॉर द एक्सक्लूडेड वेरिएबल्स इन योर मॉडल, चाहे वो एक्सक्लूडेड वेरिएबल्स आपके पास लीनियर फॉर्म में है, नॉन लीनियर फॉर्म में है, नंबर पे भी डिपेंड करता है, राइट? सो दीज आर सम ऑफ द रीजंस। आप इसको जब डिटेल से देखेंगे, इज इट क्लियर राइट नाउ?
यस सर।
राइट, जब आप इसको डिटेल से देखेंगे, सो okay, the last point that I'm trying to make before I can end this lecture is to reconsider table 2.1, और वहां पे मैंने आपको ये बताया था कि table 2.1 in our discussion represent a population, right? Let me just go back to table 2.1. When we started from the discussion of table 2.1, I had told you that this actually represents a population of 60 families. So if the population of 60 families is available to us, which means if we know the population, then of course we can talk about the PRF, we can have the PRL in the given case, and we can talk about the PRF, which in the given case is a straight line, and this will make our discussion quite easier, right? That we have to estimate a straight line. In a sense, we have to fit a straight line to our data. But as a researcher, you know quite well, आप लोगों ने इससे पहले MS level पे already आप research कर चुके हैं, even if you have not used quantitative approach, you know that in real life, very rarely we are dealing with population. Usually, we deal with what? With sample. So for example, अब imagine करें कि we don't know anything about table 2.1, which means that we don't have any idea. We don't have any idea about the population of 60 families, which means imagine that table 2.1 is absolutely unknown. What we have in real life is a random sample of, let's say, 10 families from that population of 60 families. But table 2.4 that you can see on the screen right now, and table 2.5 that you can see on the screen right now, this represents a random sample of 10 families from the population of 60 families, right? For the time being, imagine that you have this table 2.4. So in real life, when you are using data to test your theories or to verify your theory or to find answer for your search question, you have data usually from a sample. So what you would have in real life would be something like table 2.4 that you can see, or maybe another researcher have something like table 2.5, right? अब देखें ये sample किस तरह है. From each income bracket, we have selected one family at random. $80 per week, we have randomly selected a family, and randomly we have selected a family who is spending $70 per week. From the $100 bracket, we have again selected one family at random, and in this particular table, we have a family who is spending $65 per week. So table 2.4 is actually representing a random sample of size 10 from the population of table 2.1. And similarly, maybe another researcher has also drawn a random sample of size 10, and maybe another researcher has got this sample. And similarly, you can draw another random sample of 10 families and so on. Suppose, for the time being, without going into the detailed reasons how we got this thing, using table 2.4, we came up with this line, जिसको हम कहते हैं SRF1, Sample Regression Function 1. SRF1, which is represented by this solid straight line, is based on data of table 2.1. While the dotted line is obtained, जिसको हम कहते हैं SRF2, Sample Regression Function 2. This is based on second sample, right? This one as well as This one. Now the question is, which one of these two represent the population situation more accurately? Which means whether the line based on sample 1 represents the true relationship or estimates the true relationship between y and x, or whether the data, the graph on sample 2 represents a situation, right? If we want to make our decision, how can the sample data tell us something about the true picture? तो एक तो ये तरीका है ना कि चलें आप ये बताएं, if you want to decide whether the line based on sample 1, table 2.4, represents more accurately the relationship between y and x in the whole population, or whether the data in sample 2, which is represented by the solid line, by the dotted line here, whether this line represents a better picture of the relationship in the actual population, or whether the dotted line represent, ये आप किस तरह decide करेंगे? Can anybody give me a possible answer? जी
सर ये SR F1 सर स्ट्रेट लाइन सर प्रेजेंट करता है पॉपुलेशन का सर, क्योंकि सर ये स्ट्रेट लाइन ही है ना सर,
और ये SRF2 वाला नहीं है
सर। उसके आप देखें तो इसके डॉटेड जो वो आपने की सर, इसमें ज्यादातर डिस्पर्स है सर उसके।
no, let me just clarify, both are straight lines, सिर्फ इसके स्लोप और इंटरसेप्ट में फर्क है ना। देखिए अगर आप सॉलिड लाइन को देखें तो इसका इंटरसेप्ट यहाँ पे कहीं टच करेगा ना,
70 पे,
राइट? और अगर आप डॉटेड लाइन को देखें तो इसका इंटरसेप्ट यहाँ पे कहीं टच करेगा, ठीक है, 50 से थोड़ा सा नीचे।
जी जी।
और इस तरह इसके स्लोप में भी डिफरेंट है ना। यानी आप ये कह सकते हैं कि ये जो SRF2 यानी सैंपल 2 के बेस पे जो डॉटेड लाइन है, इट इज मोर स्टीपर as compared to that one. So the slope of the line based on the second sample is higher as compared to, like in a sense both represent the straight lines. The question is, जिसको Americans कहेंगे the $1 million question is, right? The question is, which line in your view represent a better picture of the actual relationship between X and Y? Remember, actual relationship is represented by this line, जिसको हम क्या कहते हैं? PRL.
Yes, sir.
This is representing the actual relationship. इसको हम क्यों actual relationship कहते हैं? Because it is based on the population data, right? ये जो दो samples मैंने आपको अभी दिखाए हैं ना, sample 1 in table 2.4 और sample 2 in table 2.5, they are just two random samples from this table, from this population. So the actual relationship is represented by this line, जिसको हम कहते हैं PRL, right? ये जो दो lines आप देखते हैं ना, जो कि अभी मैंने आपको यहाँ पे दिखाए हैं, ये वाले, they are actually SRL, sample regression line. Sample regression line based on the first sample, जो कि solid line है, और sample regression line based on the second sample, जो कि dotted line है. Both are straight lines. Both are actually representing an approximation of the PRL. Question जो मैं आपसे ये पूछ रहा हूँ कि how can you decide whether sample 1 is giving you a better picture of the actual situation or sample 2 is giving you a better picture of the actual situation? तो आपका आंसर क्या होगा? Anyone? Question आप समझ गए?
सर sample 1 सर, yes sir, सर sample 1 सर।
हाँ, क्यों?
Because सर ये पूरे population उसको सर वो फिट कर,
यानी
पूरे
आपने
population के बेस पे सर
ये कंक्लूजन आपने क्यों ड्रा किया कि sample 1 का जो लाइन है that is the better representative as compared to that of sample 2? आपकी अंडरस्टैंडिंग क्या थी कि why you are saying that?
सर because ये population based है ना सर।
नहीं, the result that you are seeing on the screen right now, right? The situation that you are seeing on the screen right now, this is based on sample data. My question is, how can you look at the sample situation to say something about the actual situation? G, any other person want to give the answer?
Sir, I think SRF2 जो है वो हमें
G. Okay, even if you are saying that SRF2 is giving us a better approximation of the actual relationship. So what is the rationale for this conclusion? उसके suppose मैं आपसे ये question कर लूँ ना कि how can you say that this is a better picture as compared to the other one? So what would be your answer?
सर उसके स्लोप को अगर हम देखें तो वो जो उनकी कंजम्पशन एक्सपेंडिचर है ना वो इनकम के साथ साथ बढ़ रहा है सर. स्लोप इसका जो है वो अपवर्ड है.
But
सर SRF1 में है फर्स्ट एक्सपेंडिचर जो है वो हमने ज्यादा किया है लोअर इनकम पे भी और सेकंड जो है वो हमने हायर इनकम पे भी एक्सपेंडिचर कम किया हुआ है.
The thing is,
sir, I think
the slope of both the lines is positive. Okay?
Yes.
Both lines are telling you that as x increases, y is also increasing. Okay? So both represent the situation that you observed in the PRL. तो एक लिहाज से तो ये PRL वाली story ही आपको बता रहा है. My question is that how can you just look at these two lines and say which one is giving you a better information about the actual PRL? देखें, इन दो को देखें and then just recall what you saw initially here. And my question is that basically तो आपका interest इसमें है ना जिसको आप कहते हैं PRL, okay? Because PRL is actually showing you the true relationship. True का word मैं इसलिए use कर रहा हूँ कि because it is based on the whole population. But because of our limitations, अगर हमारे पास ये picture ना हो and we have the picture based on the sample data, okay? So then we have, if you have sample 1, then you have the solid line. If you have sample 2, then you have the dotted line. My question is, how can you decide which line represents the true relationship between x and y? In a sense, which one is a better representative of the PRL? आप किस तरह डिसाइड करेंगे?
इसमें इस तरह हम इससे डिसीजन ले सकते हैं कि ये SRF1 जो है
जी,
ये बेटर इस सेंस में है कि अगर SRF2 को हम देखें तो इसमें ये जो कंजम्पशन है लोगों के तो ये बहुत ज़्यादा वो स्टेबल नहीं है. मतलब इनकम तो दोनों सिचुएशन में अगर हम देखें तो सेम है, लेकिन SRF2 को हम देखें तो वो कंजम्पशन में फ्लक्चुएशन बहुत ज़्यादा है. इसी तरह अगर SRF1 को हम देखें तो वो इनकम और कंजम्पशन को SRF1 में हम अगर रिलेट करें तो साथ साथ चल रहे हैं. अगर इनकम इंक्रीज होता है तो कंजम्पशन भी इसी तरह वो इंक्रीज कर रहे हैं. लेकिन SRF2 में अगर हम देखें तो इनकम तो सेम लेवल का है जो SRF1 में है, लेकिन कंजम्पशन वहाँ पे फ्लक्चुएशन ये डॉट्स ये इसमें
okay. Without disagreeing to what you have just said, my fundamental question remains that if you want to study the actual relationship between y and x, how can you say on the basis of sample data about the true relationship between y and x? The thing is, let me just give you a little bit more clear hint. देखें, मैं इसको जरा लेमैन तरीके से पहले बताता हूँ ना, ताकि बाकी टेक्निकलिटीज में तो हम बाद में जाते हैं कि फॉर एग्जांपल व्हाट्स द बेसिक सॉल्यूशन. एक बिल्कुल लेमैन अप्रोच तो ये होगा कि इफ यू वांट टू डिसाइड whether SRF1, which is based on sample 1, or whether SRF2, which is based on sample 2, would give you a good approximation. तो एक तरीका तो ये होगा कि compare these two lines with this line right? And then you can make a better conclusion. कर सकते हैं इस तरह?
Yes sir, जिस तरह आपने कहा कि अगर हम लेमैन की तरह इसको कंपेयर करें.
But then I would say that although this would be the most ideal thing, but conceptually it would be a wrong approach. Why? अब इसका आंसर दे दें.
सर पॉपुलेशन का डाटा हमारे पास अवेलेबल नहीं होगा.
Exactly. If the population data was available, then we would know this figure जो कि अभी आपको नजर आ रहा है ना, right? If the population data were available, then it would be possible to have this PRL, and then we can compare the sample picture with the population picture, and then we can make a conclusion. But this is fundamentally flawed. कि एक तो population हमारे पास usually available नहीं होता, तो इसका मतलब ये कि we have no idea कि what would be the actual PRL. But for the sake of argument, अगर हम ये फिलहाल just layman approach के लिए consider कर लें कि for example, why not just compare the two lines with the line that you can see on the screen right now and make a comparison. तो इसमें fundamental flaw क्या होगा? Okay, if the population is known, then what is the justification for sample? समझ गए आप ना?
बिल्कुल सर.
Right? Because if the population picture is already available, there is absolutely no need of wasting your time and energy and resources to focus on sample. So एक चीज तो बिल्कुल clear है कि as long as we are dealing with sample data, तो we are clear that sample data हम इसलिए यूज कर रहे हैं कि because we have no availability of population data. So if population picture is available, there is no need of sample picture. So the next thing is that, for example, if this picture is actually unknown, फिलहाल तो हम कहते हैं कि हमें पता है ना कि we pretended that table 2.1 represents a population, and then we are saying that we have two samples from that population, and then we had those sample lines. But in real life, if this picture is not available, क्योंकि we don't know this table 2.1. So if this is not available, and the only thing that we have is either this data from table 2.4, जिसको हम कहते हैं sample 1, or for example with another researcher, you have this particular data which you have, which you call sample number 2, or even for a third researcher, you can draw another random sample of size 10, right? आपको ये पता है ना कि you can draw a number of different samples. तो अगर आप एक third sample draw करें तो हो सकता है कोई इस तरह का line हो, अगर एक और sample draw करें तो हो सकता है ज़्यादा steeper slope हो. So how can you know that your estimated sample picture, जिसको यहाँ पे मैं dotted और solid line के form में देख रहा हूँ, how can you know that your sample picture is giving you a close approximation of the population picture, even if you don't know the population? Right? Let me repeat. How can you know that the sample information would give you a closer approximation of the population picture, even if you don't know the actual picture, right? There comes the role of statistical theory, right? There comes the role of statistical theory, which after this we are going to study in detail in the form of regression theory, right? The fundamental point at which I'm ending this lecture right now is this. When you want to study the actual relationship between your dependent variable and independent variable, but the population picture is not available, and that's why you are going for sample. So how can you use the sample picture? ये जो आप देख रहे हैं ना इस वक्त slide पे, SRF1 का line, this is what I call the sample picture. So whether you have got the first picture or the second picture or a third picture, a fourth picture, a 10th picture, whatever, as long as you have an outcome based on the sample data, how can you be confident that the information that you are getting from the sample data, जिसको बाद में मैं कहूँगा, how can you be confident that the sample regression model will be telling you something about the actual population regression model. लेकिन फिलहाल मैं words use नहीं कर रहा हूँ, मैं कह रहा हूँ, how can you be confident that the sample picture is as close to the population picture as possible? ये तो आपको पता है ना आपके अपने knowledge के base पे कि no matter how perfect your sample is, you cannot have exactly the true picture. Exactly the true picture तो आपको तब possible है जब आप actual population को study करें, right? But how can you be confident that without knowing the actual picture, जिसको मैं कहता हूँ population picture, you can be as close as possible to the true picture? So there comes the role of statistical theory. So the statistical theory of regression models would actually enable you to generalize from a sample picture to a population picture. This regression theory, which is based on statistical theory, that we are going to study in our next lecture, would actually clarify how is it possible to get an information based on just one single sample. देखिए, in real life, यहाँ पे तो आपके पास 2 sample आ रहे हैं ना? Real life में even आपके पास 2 sample भी नहीं होंगे. You would have just one of them. Maybe you have the sample 1, or maybe another researcher has got sample 2. Maybe a third researcher has got a totally different sample from the same population. So in real life, you would have just one sample, and in a sense, you can imagine that you would have just one line. यहाँ पे तो फिर भी आपके पास 2 lines हैं. But in real life, you would have just one line. The question would be, how can you be sure, or somehow, how can you verify that this sample picture is giving you a close approximation of the actual picture, right? This problem is solved by what we call statistical theory. Statistical theory makes it possible to get a closer approximation of the actual picture, even if you don't know the actual picture. Let me repeat what I have just said. Statistical theory behind the regression model makes it possible to get closer to the actual picture, even if you don't know the actual picture. अब ये मौजज़ा किस तरह होता है, ये फिर हम देखेंगे कि how you can generalize from sample to population. In a sense, how can you use the SRF, sample regression function, right, to generalize to the what we call the PRF, right? And the thing which makes it possible is the right methodology from the statistical theory. And as we will start right from the start of our next lecture, a very important estimation method from regression theory that we call the OLS method, ordinary least square method, makes it possible to get a closer approximation of the population picture through a sample picture. So how can you decide whether my dotted line is actually giving me a close approximation of the actual line when the actual line is actually unknown, or whether the sorted line is giving me a closer approximation of the actual line, or even a third, a fourth, a fifth, a 10th, whatever, right? This is actually based on the corresponding sequence of steps that we will discuss in detail from the next lecture, okay? So this was a very fundamental, I would say, simple discussion. This would actually, in a sense, serve as the foundation for our discussion in our next lectures. Is it okay? Should we stop here?
Yes, sir.
Right?
Yes, sir.
So our agenda from next lecture onward would be, starting from the idea of the OLS method, we would learn how can we generalize from the sample data to the population data. So in a sense, in the beginning, I would start with what we mean by SRF. I have already given you a hint that SRF, which stands for simple sampled regression function, is the population is the sample counterpart of the PRF, right? So using the sample data, we approximate a function which actually approximate the population regression function. And if we use the right methodology for getting this SRF, this will actually make that trick, जिसको मैं कहता हूं in a sense magic, which will actually bring you closer. ये हम ज़हन में याद रखें, the ending line that I would just use right now would be that even if we use the right statistical methodology, ये आप expect ना करें that sample picture would give you the exact population picture. But if you use the right methodology, you can be up to a greater degree confident that the sample picture is giving you a close approximation of the population picture, as close as possible. तो as close as possible की बात तो हम कर सकते हैं, लेकिन हम कभी ये नहीं कह सकते कि सैंपल हमें एग्जैक्टली वही इंफॉर्मेशन देगा जो कि पॉपुलेशन दे सकता है. एग्जैक्ट पिक्चर तब पॉसिबल है if we are studying the actual population. As long as you are not studying the actual population, you will always be getting a close approximation. The rest of the job that we would learn in this course would be, how can we make sure that that approximation is as good as possible, right? So that would just depend on the right methodology. So different situation में फिर हम कहेंगे कि what is actually the right methodology. So starting with the OLS method from the next lecture, we would learn how to get closer to that objective. Okay, thank you very much.
सर अगर
जी
सर अगर पॉसिबल हो सके तो काइंडली ये स्लाइड्स और लेक्चर आप
हाँ वो तो मैंने अब ये कहा ना कि in a sense I would put these slides on the university's AMS system, and if you wish I can also send these slides and other relevant material on your emails. तो आप में से आप इस तरह कर लें कि जिन कुछ लोगों के ईमेल्स तो ऑलरेडी मेरे पास हैं, जिनके ईमेल्स नहीं हैं तो आप काइंडली मुझे आप ईमेल कर दें. So I think that would also be a good way to get connected. Next lectures में I would try कि अगर कोई ऐसा relevant material है, so I would like कि मैं आपको एडवांस में वो भेज दूँ ताकि आपको on the spot available हो, आपको ये फिक्र ना करनी पड़े कि जी ये material हमें मिलेगा या नहीं मिलेगा. Don't worry, whatever we discuss, I would try कि वो material already आपके पास या available हो या आपको available किया जाए. I would just stop share right now. Okay. Should I close the recording? Okay, right now. Okay, thank you very much. See you next time, inshallah.